Hello everyone. Today we'll be starting off with module 3 titled Feedback and Power Amplifiers. So in this module we'll be studying about feedback amplifiers and output stages and power amplifiers. So this feedback amplifier forms the first half portion of the module 3 and the second half portion of the module 3 is output stages and power amplifiers. In feedback amplifiers we'll be studying about general feedback structure along with properties of negative feedback and also the four basic feedback topologies. And in output stages and power amplifiers, we'll study about classification of output stages, class A, class B output stage, transfer characteristics, power dissipation, power conversion efficiency, class AB output stage, and class C tune amplifier. So first, let's now study about the feedback amplifiers. So before moving on, we need to understand what a feedback is. So feedback means a part of the output signal is sampled back as the input to the circuitry. So it can be of two types. It can be either positive or negative. And any amplifier which has a feedback is known as feedback amplifier. Okay, and this is also known as closed loop amplifier because the amplifier that is present will form a closed loop with the amplifier. Okay, and in today's technology many of the electronic circuits will employ this feedback, and that is because in order to enhance the functioning of the system. Okay, so this is the general feedback structure wherein it has source and load at the ends, at the two extremes, and in between we have the amplifier whose open loop gain is A, and you can observe here a part of the output signal is being fed back to the input through the feedback network with feedback gain equal to beta. And we have a summer here. The output of the source is XS, that is given as the input to the summer, and output of the feedback network, that is XF, is also given to the summer as the input, and output of the summer is Xi, that is the difference of these two signals XS and XF. This is there is minus symbol here, negative symbol here, because it is negative feedback. Okay, and these signals XS, Xi and XF will represent the voltage or current of that particular system. Okay, next, this is the signal flow graph that is written for this system. The concept of signal flow graph, you have studied it in control system subjects. It is written for your reference, meaning for you to easily identify that there is a loop formed whenever a feedback is present in the circuit. Okay, and under this study of general feedback structure, we will be analyzing the closed loop gain AF, and also that the output follows input. So next we'll derive an equation for AF in terms of open loop gain and feedback gain. So gain is nothing but the ratio of output and input, isn't it? Now here first let's write an equation for open loop gain. Open loop gain of an amplifier. Consider only an amplifier without the feedback. So this part of the circuitry will not be present. Okay, so in order to write the open loop gain, the output of this amplifier is X naught, isn't it? X naught by input is Xi. So open loop gain is equal to X naught by Xi. From this we'll write X naught is equal to A into Xi. Okay, name this as equation 1. Next we'll write equation for feedback gain. Feedback gain is equal to output by input. Output is XF, input is X naught, so beta will be equal to XF by X naught. From this we can write XF is equal to beta into X naught. Alright, name this as equation 2. And the error signal, that is the output of the summer, is itself termed as error signal, that is Xi is equal to difference of X XF. So xi is equal to xs minus xf. Name this as equation 3. And next, feedback gain AF is equal to overall output by the overall input. Consider the two extremes when the feedback is present. Okay, so it will be x naught by xf. So AF is equal to x naught by xf. Now I'll consider equation 3, that is xi's equation. From this, can I write xs is equal to xi plus xf? Yes, I've written. And from equation 2, I'll substitute for xf as beta into x naught. Now I'll get this equation. And from equation 1, I will substitute for xi as x naught by a. And I'll get this. Okay. And both these two terms have x naught, isn't it? Take it as common. And the remaining will be 1 by a plus beta. So now we'll get xs is equal to x naught into 1 plus ab by a. And from equation 4, that is AF is equal to x naught by xs is equal to, see here, x naught by xs will be equal to a divided by 1 plus a beta, isn't it? xs, x naught by xs is AF. So here itself we have got the equation for closed loop open gain in terms of a and beta, that is open loop gain and feedback gain. So AF is equal to a divided by 1 plus AB. So this equation is similar to the equation of the transfer function that you study in control system subject. So for any system's transfer function is written as g of s by 1 plus g of s into h of s, isn't it? So this is similar to the equation of the transfer function. All right. Next, we will apply a condition where AB is very much greater than 1. So if for this equation, this condition is applied, A plus AB will almost be equal to A beta. Okay. So now what I have here is A divided by A beta. Both A's in the numerator and denominator will get cancelled. Remaining will be 1 by B. So this AF will depend more on the feedback gain, that is beta. All right. When compared to the open loop gain, the feedback gain is more dependent on the closed loop gain. AF is more dependent on the feedback gain, that is beta. So this is the equation for closed loop voltage gain AF. Next, we need to understand the concept that output follows input. So for that, I'll consider equation 2, which says xf is equal to beta into x naught. So I write that x naught is equal to a into xi. We know that x naught is equal to a into xi. Okay, here also x naught is equal to a into xi. Okay, you can either remember this equation or this diagram. That is what I meant to say. And I'll substitute for x naught as a into xi. Okay, and here I have a into beta into xi is the error signal, that is the difference of xs and xf. So I've written that. Next, I'll multiply ab with these two terms, that is xs and xf, and I'll get this. Now I'll group all those terms that have xf to the LHS and the others to the RHS. So here I'll get xf is equal to 1 plus xf into 1 plus ab is equal to xs into ab. So now xf will be equal to 1 plus, sorry, a beta by 1 plus a beta times the xs. Now if I apply this condition wherein a beta is very much greater than 1, so here 1 plus a beta will be almost equal to 1 plus a beta alone. So the numerator and denominator ab will get cancelled. So now xs is equal to xs. So go back to the figure to analyze. XF is equal to XS, meaning XI, that is the error signal, will almost be equal to 0, and the output will be equal to XS, isn't it? So which is the input? Output, I'm repeating in one thing once again, output will be equal to input, meaning X naught will be equal to XS. So the output will follow the input, isn't it? So that is the concept. Output follows input. See here, XF is equal to XS. So this is about the general feedback structure. The next session we'll continue up with module 3. Thank you.